Welcome to Kubernetes Crashcasts. I'm Sheila, and I'm here with Victor to dive into the exciting world of Kubernetes. Before we begin, we'd love it if you could rate our podcast on your listening platform. It really helps us reach more listeners and continue creating great content for you. Today, we're starting our journey with the first episode of our Introduction to Kubernetes season, focusing on what is Kubernetes. Specifically, we'll be covering an overview of container orchestration. Victor, are you ready to get started?
Absolutely, Sheila. I'm excited to kick off this season and help our listeners understand the fundamentals of Kubernetes. Before we dive in, let's start with a fun quiz question for our listeners. Here it goes. What do you think container orchestration has in common with conducting a symphony orchestra?
Ooh, that's an intriguing question, Victor. It really makes you think about the parallels between technology and music. I'm sure our listeners are pondering this connection right now. While they think about it, let's begin our discussion. Victor, could you start by explaining what container orchestration actually is?
Certainly, Sheila. Container orchestration is the automated process of managing, scaling, and maintaining containerized applications. But before we dive deeper, let's break down some key terms. Containers are lightweight, standalone packages that include everything needed to run a piece of software. This includes the code, runtime, which is the environment where the code runs, system tools, libraries, and settings. Orchestration, in this context, refers to the coordination and management of these containers.
That's a great explanation, Victor. So, if I understand correctly, container orchestration is like having a conductor for our containerized applications. But why do we need this orchestration? Aren't containers supposed to be self-contained and easy to manage on their own?
Excellent question, Sheila. While containers are indeed self-contained, when you're dealing with modern applications, you're often managing hundreds or even thousands of containers across multiple servers or cloud environments. This is where container orchestration becomes crucial. It helps automate many of the complex tasks involved in managing these containers at scale.
I see. So it's about managing complexity and scale. Can you elaborate on some of the specific benefits of using container orchestration?
Absolutely. There are several key benefits. 1. Automated deployment and scaling. Container orchestration tools can automatically deploy containers based on your specifications and scale them up or down as needed. 2. Load balancing. They can distribute network traffic across multiple containers to ensure optimal performance. 3. Self-healing. If a container fails, the orchestration system can automatically restart it or replace it with a new instance. 4. Resource management. It efficiently allocates CPU, memory, and storage resources across your infrastructure. 5. Service discovery. Containers can easily find and communicate with each other, even as they're created, destroyed, or moved around. 6. Rolling updates and rollbacks. You can update your applications with zero downtime and easily roll back if something goes wrong.
Wow, those are some impressive benefits. It's starting to remind me of our quiz question about the symphony orchestra. Just as a conductor coordinates all the musicians to create beautiful music, container orchestration seems to coordinate all these different aspects to create a smoothly running application. Is that a fair analogy?
That's an excellent analogy, Sheila. Just like a conductor ensures that each musician plays their part at the right time and volume, container orchestration ensures that each container runs when and where it should, with the right resources. And just as a conductor can adjust the performance in real time, container orchestration can dynamically adjust to changing conditions in your application environment.
That really helps put it into perspective, Victor. Now, could you tell us about some of the basic components that make up a container orchestration system?
Certainly. While different container orchestration platforms may have varying architectures, there are some common components you'll find in most systems. 1. Cluster. This is the entire set of machines, physical or virtual, that run your containerized applications. 2. Node, a single machine in the cluster, which can host one or more containers. 3. Container runtime, the software responsible for running the containers, like Docker. 4. Orchestrator, the core component that manages the overall state of the cluster and makes decisions about placement, scaling, and lifecycle of containers. 5. API server, provides an interface for users and other components to interact with the orchestration system. 6. Scheduler, responsible for assigning containers to nodes based on resource requirements and other constraints. 7. Controller manager, monitors the state of various resources and works to maintain the desired state. These components work together to provide the powerful features of container orchestration we discussed earlier.
That's a comprehensive breakdown, Victor. It's fascinating to see how all these components work together. Can you give us a real-world example of how container orchestration might be used in practice?
Absolutely, Sheila. Let's consider an e-commerce website during a holiday sale. The site experiences a sudden surge in traffic, and container orchestration comes to the rescue. The orchestration system detects the increased load and automatically scales up the number of container instances running the web server and database. It distributes the incoming traffic across these new instances, ensuring the site remains responsive. If any container fails due to the high load, the system automatically replaces it. Once the sale is over and traffic returns to normal, the orchestration system scales down the extra containers, saving resources and costs.
That's a great example, Victor. It really illustrates the power and flexibility of container orchestration. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course. The answer to what does container orchestration have in common with conducting a symphony orchestra is that both involve coordinating many individual components to work harmoniously together. Just as a conductor coordinates various musicians playing different instruments to create a cohesive musical piece, container orchestration coordinates multiple containers, each running specific services, to create a smoothly functioning application ecosystem.
That's a beautiful analogy, Victor. Now, let's summarize what we've learned today. Container orchestration is the automated management of containerized applications. It's crucial for handling the complexity of modern large-scale applications. Key benefits include automated deployment and scaling, load balancing, self-healing, efficient resource management, service discovery, and seamless updates. The basic components of a container orchestration system work together like musicians in an orchestra to create a harmonious application environment. Remember, listeners, this is just the beginning of our journey into Kubernetes. In our next episode, we'll dive deeper into the history and evolution of Kubernetes. Don't forget to visit crashcasts.com, join our Discord community, and if you're enjoying the show, please support us on Patreon. Your support helps us continue creating great content for you. Thanks for listening, and we'll see you in the next episode.